In this two-way contingency table, we have 1,300 students in this study, so we have two variables, their major and the number of hours they study every week. So let's take a quick tour to the contingency table. So we have this joint frequency. So we call them joint frequency because every one of these number corresponds to two status. So let's say we have 100. So we have 100 students. We have 100 students. They are humanity major and they study more than 20 hours per week. And then we have 0 students. They are social science major. They study more than 20 hours per week. We have 0 engineering students. We have 0 engineering students, and then they study 0 to 10 hours every week. So that's how the joint frequency works. And then let's get rid of these marks. Let's take a look at the column total. So each one of these columns, humanity, we have 17 plus 43 plus 100 equals to 60. Same thing for the rest of the columns. And then we have a row total. We have 100 plus 0 plus 72 plus 175 equals to 377. And that's how everything else works. All right. Okay, let's take a look at the first problem. Part A is the probability that students study 11 to 20 hours per week. So A is probability 11 to 20 hours every week. So this one is we have to take the sum of that event, which is 609, and then divided by the grand total. So that is 609 divided by 1300. If you want to do a quick approximation, then you take 609 divided by 1300. Usually for probability, we leave the answer in 4 decimal places, which is 0.4685. All right. And then in part B is an engineering major. So how many engineers do we have? We have 385 engineering. So that is 385 divided by the grand total. All right. What about C? C is a business and study more than 20 hours. So C is probability, business, and study more than 20 hours every week. So this one we have to take a joint frequency divided by the grand total. Business and 20, the business and study more than 20. So business and study more than 20 is 72. So we will take the 72 divided by the grand total. All right. So that is equals to 72 divided by 1300. So that is for part C. And then part D is business or more than 20. So D, we have probability of business or more than 20. So this is one event or the other. So using the inclusion-exclusion principle, we have probability of business plus the probability of more than 20 minus the probability of business and more than 20, which is both event, right? So we found that in the previous subproblem. So how many business majors do we have? The answer is 472 divided by grand total. How many more than 20 hours? 337 divided by the grand total. So when you solve this kind of problem, make sure that you have the same denominator. Otherwise, you make a mistake. So 472 plus 337 minus 72, then you have 737 divided by 1300 as your final answer. So that is D, and then E is engineering and study 0 to 10 hours per week mutually exclusive. Are they? So let's find out. So E is probability of engineering and, don't close the parenthesis yet, and 0 to 10 hours every week. So for the N, we have to look for a joint frequency. So engineering and more than and 0 to 10. So engineering and 0 to 10, the joint frequency is equals to 0. So since this is a 0 divided by the grand total, that is equals to 0. So we say that they are mutually exclusive. What if the probability is not equal to 0? Then they are not mutually exclusive. So 0 means these two events, they do not share anything in common. That's why the joint frequency is equal to 0. So they are mutually exclusive. If there are some students in the joint frequency, then they share those students in common, then they are not mutually exclusive. F is calculate the probability that the student is engineering or studies 0 to 10. So F is probability engineering or study 0 to 10. So this one we have to do the plus and then subtract, right? So that is probability of engineering plus 0 to 10 and then minus their joint frequency. Let's just call this a both. Both means engineering and 0 to 10 hours every week. So how many engineering major do we have? We have 385 divided by the grand total. And then 0 to 10, how many 0 to 10? We have 354 divided by the grand total. And then what about the joint frequency? Engineering and 0 to 10, this is a 0, right? So then we have to subtract 0 divided by 1300. Do you see that they have the same denominator? So that means I am on the right track. So we have 385 plus 354, that is equals to 739 divided by the grand total. That is my answer. And then G, if two events are mutually exclusive, then these two events are independent, true or false. The answer is absolutely false. Because mutually exclusive and independent, they are two different things. There is no way to pull them together, right? Just like apples and orange. You cannot pull them together. They are two different topics, all right? So it's absolutely false. There is no relationship between mutually exclusive and independence. So that is G. And then we have H. Find the probability that this student study more than 20 hours per week, given that this student is an humanity major. So H is probability given humanity. What are we looking for? Looking for more than 20 hours per week, right? So this one, let me copy the table over here. So humanity, how many humanity do we have? Humanity, we have 160. That is the strategy to answer conditional probability. Whatever is given, you find the total, you put the total in the denominator. So we are locked in the first column, right? So within the first column, how many people study more than 20 hours per week? The answer is 100 people. So there you go. That's the answer. H, and then I is suppose a student studies 0 to 10 hours per week. So I is suppose means given. 0 to 10. Find the probability that this student is an engineering. How many 0 to 10 do we have? The sum is 354. So within the first row, how many engineering major? 0. So the probability is equals to 0. So that is I, and then the last one is J. Engineering and 0 to 10, are they independent or dependent? So J, we have probability of engineering and 0 to 10. So to prove that two events are independent, so the N must be equals to the product of each of the two single events. So engineering multiply probability 0 to 10. So engineering and 0 to 10, what do we have? Engineering and 0 to 10, we have a 0. So this is a 0 divided by the grand total. That is mutually exclusive, right? And then engineering, how many engineering? That is 385 divided by the grand total, 0 to 10, that is 354 divided by the grand total. There is no way that the product of these two fractions is equals to 0. So they are not equal, right? So they are not equal. Not equal means they are not independent. Not independent means these two events, they are dependent. So that's how you answer this question. Don't just say independent or dependent on your paper. You have to provide a full explanation to get credits. All right, so that will be all in this contingency, two-way contingency table probability. I see you all in the next problem.